Hello everyone, welcome to my channel for another interesting video. The topic of today's presentation is highly relevant not only for career aspirants but also for creating mass awareness about the repair of degraded and contaminated ecosystems. So learn with me, I am Neelam Mishra. As we all know, chemical contamination of our environment has been a highly visible and undesirable outcome of industrialization. Nowadays, the food that we eat, the water we are drinking, the air we are breathing, or the land we are living on, everything is contaminated with harmful chemicals and pollutants, primarily due to increased anthropogenic activities in every sphere. Different kinds of pollutants such as agrochemicals, nuclear waste, heavy metals, greenhouse gases, organic solvents, xenobiotic compounds are not only devastating our environment but taking a heavy toll on our health. In addition to these pollutants and toxicants released from the industries, occasional but serious occurrence of environmental disasters such as oil spills in oceans, Union Carbide Bhopal disaster, release of radioactive material in Chernobyl accident, and most recently from Fukushima reactor in Japan are aggravating the health risk and pollution threats. Some of these pollutants are known to exert carcinogenic and or mutagenic impacts and thus must be handled carefully or removed on a priority basis to prevent environmental catastrophe. As is clearly evident worldwide, environmental cleanup has become a necessity and is a matter of global interest and action. In an effort to repair the contaminated environment, many of the chemical and physical techniques used for site cleaning or detoxification of harmful pollutants in the past are unreasonably expensive and do not provide permanent solution. So the million-dollar question is, how can we decontaminate our environment sustainably, efficiently, and in a cost-effective way? In view of this urgent need, scientists have devised a technique called bioremediation, which is considered as an attractive emerging approach for sustainable cleaning up of contaminated environment and waste management. Biological technologies for remediation are often sought because they are less expensive than mechanical ones. This is because the biological catalyst multiplies at the expense of the pollutant and thus naturally enhancing the remediation rate, and low-cost resources are usually needed to implement the technology. Bioremediation technology has made it possible to decontaminate soil and groundwater and has helped us clean our oceans after oil spills and other environmental disasters. With this overview, it is important to know the exact meaning of the term bioremediation in order to develop a better understanding of today's topic. I will also include the discussion on the types of bioremediation, followed by advantages and disadvantages of this technology. The word bioremediation can be broken down to two parts. Bio, which means life, refers to living organisms, and remediation, which means correction of something or treating the situation. So, building off the definition, bioremediation is a process where biological organisms are used to remove or neutralize an environmental pollutant by metabolic process. In simple words, bioremediation is a means of cleaning up contaminated environments by exploiting the diverse metabolic activities of biological organisms to convert harmful materials into less toxic or harmless forms. Bioremediation utilizes the great diversity of organisms in nature, such as bacteria, algae, fungi, and plants, and their catalytic enzymes, because it is this variation that results in the often novel biotransformation capacities. Microorganisms are found in the widest range of habitats in the Earth's biosphere and thus are the perfect candidates for acting as Earth's garbage control agents as well as environmental caretakers. Before I move on to discuss the types of bioremediation, let me briefly tell you about the history of bioremediation. Bioremediation was invented by George M. Robinson in the 1960s. The first commercial application of bioremediation was made in 1972 for the Sun oil pipeline spill in Ambler, Pennsylvania. Later on, bioremediation technique was extensively used in cleaning of Exxon Valdez oil spill in 1989. Since then, there have been significant advances in bioremediation techniques, with the ultimate goal being effectively restore polluted environment in an eco-friendly approach at a very low cost. In the past 2 decades, bioremediation technologies are being used enormously in waste treatment and have proven effective and reliable in removing toxic chemical waste or physical hazardous material from the surrounding. Now let's turn our focus on the types of bioremediation, which can be classified into various types depending on the basis of the organisms used or the strategy employed or the mechanism of degradation involved in the process. First, on the basis of the biological organism used, bioremediation is of 3 types as depicted in this slide: bacterioremediation, mycoremediation, and phytoremediation. Bacterioremediation involves the use of aerobic and anaerobic bacteria to neutralize and remove various kinds of pollutants. Mycoremediation involves the use of fungal organisms to break down contaminants into harmless substances, whereas phytoremediation utilizes several plants to bind, stabilize, extract, reduce, and remove contaminants in sediments, soil, water, etc. Plants have the unique ability to store polluting heavy metals in their tissues. Second classification is based on the principle of degradation, which divides it into 2 types: biotransformation and biomineralization. In the biotransformation process, organic components are partially degraded and the remaining portion is transformed into other harmless and less toxic organic matter. On the other hand, biomineralization involves the conversion of organic waste nutrients into inorganic materials, substances like water, carbon dioxide, etc. A point to emphasize here is that bioremediation and biodegradation should not be confused with each other. Bioremediation as a technique may include biodegradation as only one of the mechanisms involved or applied in the process of bioremediation. And thirdly, there are principally 2 ways of bioremediation with regard to the site of application or the place where contaminants are removed or treated. That is, in situ and ex situ bioremediation. In situ bioremediation techniques involve treatment of the polluted substances right at the contaminated site to eliminate them from the contaminated ecosystems. On the contrary, the process of ex situ bioremediation takes place somewhere out from the contaminated site and therefore requires the excavation of the pollutants from the polluted sites and subsequently transporting them to the site of bioremediation. As you can see on this slide, both in situ and ex situ bioremediation involve various techniques depending upon the specific methodology or approach used for environmental cleanup. I will explain each of these bioremediation techniques in the next upcoming video. Ex situ techniques are ought to be more expensive as compared to in situ bioremediation. Hence, in situ bioremediation is considered as a superior method for the cleaning up of the contaminated environment because it saves transportation costs and uses harmless organisms to eliminate the pollutants. Moreover, it does not require any excavation, therefore it is accompanied by little or no disturbance to the structure. Although bioremediation is a very promising, fruitful and appropriate technology for cleaning, managing and recovering materials from earlier waste as well as to clean current waste streams, we cannot say bioremediation is 100% universal solutions for environmental rehabilitation or decontamination of polluted environment. So further discussion is confined to the factors that limit bioremediation. The limitation of bioremediation technology are usually due to the lack of any known organism with the capacity to transform a specific pollutant or the absence of the appropriate organism at the particular pollution site. Biological processes are highly specific and thus require suitable growth conditions and availability of optimal level of nutrients and contaminants for successful detoxification. It is difficult to scale up bioremediation process from batch and pilot scale studies applicable to large-scale field operations. Usually, bioremediation techniques are time-taking processes and are limited to those compounds that are biodegradable. Environmental biotechnology can play a vital role in overcoming all these limitations. Through the science of bioprospecting, it can help in identifying appropriately qualified living organisms and employ genetic engineering to improve the efficiency and cost, which are the key factors in the future widespread exploitation of organisms to reduce the environmental burden of toxic and harmful substances. There is no doubt that bioremediation is likely to become a preferred technology and is the need of the present world that can lead to protection and preservation of natural resources and Mother Earth. On this note, I wrap up this video. I have tried to cover all the points to make you understand the term bioremediation, types of bioremediation, its advantages and disadvantages. I will elaborate more on bioremediation techniques in the next video, so don't miss the upcoming video and stay tuned. If you have any queries, please write in the comment box for a quick reply. I thank you all for your attention and support. Hope you are having a great learning experience with BioShots. Thank you once more.